Now, we've already covered the direct proportion and the inverse proportion. And those are the basics of all of the proportion problems. Now you can combine them, put them together, and that would be like joint or combined proportion problems. So let's look at something that would indicate that you are going to kind of put things together. Suppose that x, y, and z represent three quantities. When a variable quantity is proportional to the product of two or more other variables, we say that it varies jointly. So, all of that rigmarole for you to see, anytime you see something that says y varies jointly with x and y, we're going to set it up to look something like this. So it's like a direct proportion problem, but it's not just directly proportional to x, it's also proportional to z as well. So it varies jointly with x and z. If we see something that says that y varies directly with x and inversely with z, that's putting direct and inverse proportions together. So here we have y equals kx, so it varies directly with x, and inversely, meaning the division, with z. Now, we could even put more of them together than that. If it says y varies jointly with m and n, then that means that we are multiplying m and n, and inversely with p, then that's a division of p. So that would look something like this. So you can put all of these together in multitudes of ways. Let's work a problem that combines some things. This one says, suppose that y varies jointly with x and z. So that's going to tell us that for our step 1, creating our generic formula, we're going to say y varies jointly, meaning together, with x and z. There's no inverse in there for us to do a division, so it's just multiplication. Now, step 2, remember, they will give you enough information to be able to solve for k. So here in our problem it says y equals 20, x equals 6, and z equals 10. So if y equals 20, x equals 6, and z equals 10, we have been able to replace every variable except k. So now we can solve for k. So that means 20 would equal 6 times 10 would be 60, so 60k. And then dividing both sides by 60 and reducing our fraction, 20 over 60 will reduce to 1/3. So now we know that k equals 1/3. Once we know what k is, step 3 is to rewrite our original formula using your newfound k value. So this would be y equals 1/3 times x and z. The last step is always to answer the question that they actually asked. Find y, so we don't know what y is, but we do know that k is 1/3. If x equals 8, so we're replacing x with 8, and z equals 15. Now, because this is multiplication and we can do it in any order we want to, we could cancel the 3 into the 15 5 times, and then we have 1 times 8 times 5, so y will equal 40. This is our final answer.